This lecture video is going to go over real quickly some of the different things that can actually affect the rate at which blood is flowing. And really, most of it is going to be whether or not we're opening or closing our blood vessels. So first of all, obviously your nervous system is going to play a role. And your nervous system is going to do or affect hemodynamics or blood flow in basically two general areas. First, we're going to look at receptors. So there are baroreceptors. These are going to be receptors that detect changes in pressure. So these are located all over. Specifically, there are baroreceptors located within your kidney that's going to monitor the blood pressure. And if that pressure, which is going to be directly related to flow, right? If you don't have a strong blood pressure, you don't have a strong blood flow. If those baroreceptors recognize that there is a problem in the blood pressure, whether it's too high or too low, then it will send signals then for the nervous system to make adjustments, which again, typically is going to involve either making your vessels smaller, constricting them, okay, that's going to increase your blood pressure, or making them bigger, which is going to increase the flow and decrease the blood pressure. Chemoreceptors are going to be those receptors throughout your body that detect changes in chemicals, specifically in terms of blood flow, looking at the levels of oxygen, the level of carbon dioxide, and then the pH level. So if you have an increased amount of carbon dioxide or a decreased amount of oxygen, and chemoreceptors sense that, it's going to increase the blood flow through the capillaries. So basically it's going to open up valves in the capillaries to let more blood flow through them. If you have a drop in CO2 or you have an increased level of oxygen, then what's going to happen is those capillaries are going to shut off those valves and they're going to decrease the blood flow. And that will ultimately lead to an increase in pressure. So chemoreceptors will monitor the chemicals and make adjustments, and then baroreceptors will monitor the pressure. Your nervous system also regulates blood pressure, specifically the sympathetic system, and it's going to regulate that mostly through the release of hormones called epinephrine or norepinephrine. So some of the things that can affect sympathetic system stimulation are going to be increased exercise. So if you're working out, what's going to happen is the blood vessels that are in your skin are going to constrict and they're going to push the blood to your muscles, which need more oxygen and more energy. So when we talk about monitoring blood flow, we don't just talk about the entire body, because there are times where we want, like in the case of exercise, we want our muscles to have more flow. And in order to get more flow to our muscles, we have to take away the flow from someplace else, such as our skin. So usually when we have to adjust the blood flow in our body or the blood pressure, we're doing it in different areas. And as one area increases flow or increases getting more blood supply to it, another area is going to lose some of its blood supply. So anytime you have an increase in body temperature, that's going to be detected by the hypothalamus. That's going to cause your blood vessels in the skin to dilate or get bigger, so to bring more blood to that area. If you have a decrease in body temperature, the opposite will happen. So again, the blood vessels will constrict, so blood will get diverted away from your skin. If you have a decrease in body temperature below a critical level, so if you start to experience hypothermia, what's going to happen is the blood vessels are going to then dilate. They're going to get really, really big. So normally what would happen is the blood vessels would constrict, but once we hit a point, a critical point, then all of a sudden the blood vessels are going to get really, really big and cause flow to increase to that area. Also, stress, anger, embarrassment, typically that causes dilation of blood vessels in the skin of our face and our upper thorax, so that's why we start to turn red or we start to feel a lot of heat in those areas when we're embarrassed or we're angry. That's because we're increasing the amount of blood flow. So again, thinking about the sympathetic system, which responds to stress, stressful situations, depending on the situation and depending on the area of the body, blood flow will be diverted to different areas, to the skin, to our face, to our chest, to our muscles, depending on what it needs. And finally, blood flow can be regulated by hormones. Hormones are either going to act as a vasodilator, so they're going to, vasodilation just means making our blood vessels bigger, or vasoconstrictor, making them smaller. The biggest hormone is going to be epinephrine and norepinephrine. So if we have any kind of increase in physical activity, or if we have an increase in sympathetic activity, that's going to cause epinephrine to be released, and typically it's going to cause constriction of blood vessels in the skin, but it's going to cause dilation of blood vessels in our skeletal and cardiac muscle. So again, this would make sense because in a situation where we're stressed out, we want to have more blood diverted to our skeletal, our muscular system, and our cardiac system in order to provide them the things they need to get our heart beating faster and our blood flowing and more energy to our muscles so that we can run, fight or flight. And because we're diverting blood to those areas, we're going to lose blood near the area of the skin, so they'll constrict. So I always think it's interesting that these hormones can have a different effect on blood vessels in different areas. And then the renin-angiotensin-aldosterone system, this is going to be located within the kidneys. We'll talk a lot more about this in the last unit when we look at the kidney system and the renal functions, but they're also going to be released in response to changes in blood pressure and in order to alter the blood flow in order to bring pressure up or down to fix the problem. So if there's a drop in blood pressure, these chemicals will be put into motion in our body in order to bring pressure back up to where it needs to be for us to be functioning. It is kind of important to know that most of our blood flow will be regulated at that arterial, in between the capillaries and the arterioles. In that particular area, that's where a lot of the different either dilation or constriction is going to occur as we try to adjust for blood flow. So those are just some examples of how our nervous system and how our endocrine system function to control blood in our body, the flow of blood in our body, and ultimately this is going to affect blood pressure.